Nigerian man will keep it. I will not say it's bad again. Because I have learned to install one of them. One of them is Fusion 360. If you are not yet installed Fusion 360, it's already too late, and I'm not going to pause or wait for you. So it's up to you. If you have not installed it, or you have any difficulty with it, and you have not talked anything about that, that is your cup of tea. Right now, we are looking at the Fusion 360 modeling environment. So today, we are going to be looking at the politics interacting with Fusion 360, the graphical user interface, GUI, the timeline. We will take a look at a demo. And I think by the time we finish the demo, today's class should be over. If we have time, we can take a brief look at the API approach. And the remaining of it will not be covered in today's class by my own calculation. So let's just see how far we can go today. Interacting with Fusion 360. Fusion 360 is an enormous graphical engine that enables you to do collaborative 3D solid modeling in the following specializations: freeform or artistic modeling, direct technical designs, data-driven or parametric designs, surface modeling with a special toolbox for sheet metal models, which are shed-like objects such as motor car or truck bodies, water and fuel tanks, and so on. Those are sheet metal models. Then you could also edit imported meshes from other CAD software. All these things can be done in 360 environment. So these are the things that are possible. Now, you could go to YouTube and you will see tons, if not thousands of teachers who teach you how to do Fusion 360. Fusion 360 is the flagship of one of the earliest players in CAD design, a company called Autodesk. I have been using their software since 1992, and I have been active to date. Yet, I still consider this an enormous software. Despite the long years of association with it, the thing continues to get bigger and bigger, having more and more capabilities and power. And it has never been as powerful as it is today. So it is a very powerful and capable software that even the best of you, with all the dedication, you probably will not be able to use up to 8% of it, even if you are doing nothing apart from Fusion 360 for the entire year. So it's a heavy program, but so you have to be very careful and really know what you really want to learn. So I will try and guide you. And so the guidance you will get is not trivial. So it's up to you to take the information and instruction you get. To get the best benefit of this tool and develop marketable and superior skills, it is important to be clear on your goals and find ways to achieve them. If you just go dabble into it and you are just doing trial and error, well, you might get something out of it, but I think the person who really has a specific set of goals and is given some specific set of instructions will likely achieve things better. There are many good teachers on the web, and there are also several incompetent teachers. There are people who shouldn't be teaching others who are trying to. If you want to learn 3D solid modeling, learn from the masters. I will tell you who the masters are, and I would show you where to find the best materials to learn with. Before taking any course from a random YouTube guru, check what the manufacturer of the product offers first. The manufacturer product has a lot of stuff already available for free for you. And I think, in my opinion, those people who are directly related to the manufacturer or indirectly related to them, my opinion and experience is that those are best teachers. So there's a very technical product, and there are people who don't know much technical science that are just dabbling into it. Well, just we'll see as we go on. The purpose of this course is for you to do solid modeling for the purpose of engineering. So we discussed what engineering is last week. And here we are talking of solid modeling, particularly directed at engineering. Fusion 360 can be used by anybody, can be used by an artist. And if you learn Fusion 360 as an artist, it's good. You can live and earn your daily bread with it. If you are already a very good artist, Fusion 360 can leverage your skills and make you a fantastic artist. Use things that you probably could only have dreamt of before. If you are an interior decorator, Fusion 360 is fantastic. Purpose. It's actually a general purpose design tool, so which can be used by anybody. But for an engineer, Fusion 360 is also very, very, very good. It is designed for the engineer primarily. And for an engineer, it is not only just there to teach you how to draw, how to design. It carries you through the entire design process, including manufacturing, using latest manufacturing equipment. So it has in fact, there are many of the equipment sellers advise you to install Fusion 360 because instead of writing their own software for their equipment, they depend on Fusion 360 for use. So some of the experts that are teaching on the web are not in engineering and are teaching the general populace. Their work may not be the best for you. And there are two ways of using Fusion 360, the interface and the application programmers interface. Whereas many people will teach you the graphical user interface, it's only a restricted number of people that will teach you the application programmer interface because this one is a little bit more technical. You need to be relatively advanced. This is relatively advanced in the sense that it assumes you have a background in a programming language such as C or Python, in an object-oriented programming language. If you approach it as an engineer, this tool has something to add to 60% of all in the university. And even all the way to postgraduate to PhD, there is a lot that Fusion 360 can still add to your knowledge. It is as powerful as every textbook you will read because a lot of the equations, formulas, results, designs, and many of the things you will arrive at in your regular courses are already pre-programmed inside. There are simulation packages that are already there. So what happens when you launch Fusion 360? You are facing a screen that looks very much like this. The top of that screen is what we call the applications bar. Applications bar. That is the top of the screen. So whenever you just launch Fusion 360, you will have something like this. And then immediately below the application bar, you have the workspace. Then you have the view cube. Onto your right here, there's a view cube. Onto your left, you have what is called the browser. I'll talk about these things later. On the bottom left is you have a timeline. We'll talk about that. And then you have a navigation panel, and you have this gear. There's this gear icon on the bottom corner. So that's then the large area that is relatively empty is the canvas. Inside that canvas, that's where all your design. By the time we get some distance into this lecture, we are going to go through some simple things, and then we will be able to show how to really, how these things behave and what they do. The application bar, I think Autodesk call it the application bar. So let me just use the terminology. The application bar, the top center of your user interface notifies you on the current and active designs, including where they are located, what they are named at, and then the version type, the drawing and projects. That is the first thing you look at, and that happens around here. Right now, because we have started anything, what you have there is going to be untitled. That is, there is a project open or a file open called untitled. So that is where, before you title anything. So once you name that, that is the font. So no matter what, as long as you are in the Vision 360, you will have something called untitled until you name it. To your left on the application bar, you have the data panel. The data panel is the first thing you have, and it toggles display the menus that manage design data. And let us see, this is, you have it here. It's just showing you like a tile of icons there, about 9 of them. So if you click on that, you will toggle in between your data and then it goes on and off. From there, you have several other icons. The other icons, for instance, the file icon is something very familiar. If you have done anything on Windows, it is a familiar stuff. Then you have a floppy disk there, which helps you to save. Here you have undo and redo. All those things are standard for anybody who has any experience with in any programming environment involving Windows 10. And then here, in this large side here, you have the center side here, you have where your files will be shown. So there will be a tab of files here. So you can open several files at once, sometimes up to 20 files or more. So you are working on. The one that is active will be the one that will show you here. So if you are using to the tabbed menu of Windows 10, and then the plus sign you see here is a shortcut for the file, create a new file or open a new file. And then all the other ones here, I think I can't see some of them clearly, ends in a help menu. And then you, like here, you have my photograph. If you have properly installed and you see photograph here. If not, you might see your name or your sign-on name here. So we will take a look at what all those things do. The next thing here is you have workspace. You have the workspaces tabs and toolbar. So you have the workspaces tabs and toolbar next, and there, because Vision 360 arranges itself into workspaces. The default workspace is the design. You will find out that there are other workspaces like simulate, animate, drawing, several other ones that you will look at. We will take a look at this render workspace. And the workspace you choose will determine the toolbar and the toolbars and all these other, the toolbars and tabs that you will see here will depend on what workspace you choose. If you choose another workspace, all these things may change. There are some toolbars that function across workspaces. You will see them too. So this right now in the design workspace, you have a number of tools that help you to create. So depending on what you want to create under design, and then modify. Some allow you to assemble. Then you can construct. This one is what you use to construct construction lines and some other things you want to construct. That's not part of your drawing, but that aid catalysts to your drawing, construction catalysts to your drawing. And then here you have inspect this to see, to take a look at your drawing. And then this is a start and select. We'll go to, when we get to a practical session, we will see how this was work. And then, like I said, this is the browser here. You have the browser on this side. And then you have the timeline below. And then the navigation bar helps you to navigate. And let us just take a look at some of these things one by one. Like I said, the application bar notifies you drawings and projects. The data panel toggles display the menus that manage your design data. And then there is an icon there for your account. And then, most importantly, when you have a question mark, which is the help menu, you can move through that to a very interesting part. If you want to get the videos that train you on Fusion 360 before you start following any guru on YouTube, better check out the videos from the experts that you can reach here. I will take you through those videos, which is the question mark on the application bar. After you have clicked that question bar, you choose learning and documentation. If you, from learning and documentation, you'll be able to choose self-paced, and after self-paced learning, you can get to videos. I'm going to take you through all of this until we reach videos. I will play one video from beginning to end for 5 minutes. Then you will now see how to get to other videos there. Then the workspaces, as I said, you have tabs and toolbar. On normal launching, the first thing is you are put at the design workspace. You have things that help you to do solid surface, sheet metal, and all that, and tools. The following tools set changes with the selection of any of these, giving you tools that are available in each. Some tools are available for multiple things. Then you have things like generative design, render, animation, simulation, drawing workspace. Like that. For in this first course, we are going to spend most of our time in the design workspace. We will do some bit of animation, a little bit of simulation and drawing. I will not do any rendering. And we will look at the simulation and drawing workspaces in this course. I will not do anything in the render workspace. And I'm not going to tell you not to go there, because I know even if I tell you not to go there, you are not going to obey me, you are going to go there. And I have learned that from several sets of students I have taught. The students like the render workspace a lot. And because of that, I don't do anything there, because I know you are going to go there. And students quickly become experts in the render workspace because it helps them to create photorealistic, which they like a lot. And my experience is that students are so fascinated with the capabilities of the render workspace that I have stopped telling them not to go there too early. They are going to go there, whether you like it or not. So if I say don't go to render workspace, you are going to go there. So I let you go there and please yourself. It is a very nice thing, but it's not one of the things I'm going to spend my time on teaching you. Now, we talk about the browser. The browser is one of the areas you spend a lot of your time in. The browser, first of all, gives you the name of the active file. Like here, it can be TSET01 version 1. It gives you the name. It gives you a lot of information about your document settings. And if you click the arrow here, it will give you more information on your document setting. The second thing there, it tells you about named view and view your origin information, the information about the origin and axis and all the things that are pertaining to your present settings. It is not unusual for you to turn it off. Like in this particular drawing, my origin is turned off. When I go to Fusion 360, I'm going to turn it on and off. So you'll see why you turn it off sometimes. And in particular drawing here, components, particular drawing, it's a component of a turbine, which has a volute and an impeller. So the volute, all the things contained in the volute contains its own origin. It contains bodies, backplate, outer cap, inlet cap, and so on. And then sketches. Sketches are the two-dimensional sketches that created the volute in the first place. So all of that are inside. We will see. Then you have the impeller again. Every component has its own origin, which is because there are so many origins and they confuse you. So it is always, they are very useful, but many times you want to turn them off because when there are too many of them, the drawing becomes busy. There's own sketches, construction, and so on. So In the browser, several detailed actionable information on your design is presented. It provides optional ways of interacting with your design. In the example here, the browser shows us that we have two named components in the drawing, the volute and the impeller. We would see that in direct details when we go to the practical section. So we will do that. And I think at this point, it's better for me to launch Fusion 360, and you'll see that example. Where is it now? Okay, so take this. This is an example of my Fusion 360 drawing that has the browser here, and the browser contains, let us see, if we close everything, you see that there are two components, the volute and the impeller. Here I've turned off the volute. If I turn on the volute now, you see the volute. The reason why I turned off the volute before is because I wanted, let's see, let me undo that. I wanted you to be able to see, what is inside. This is an example of what you might have. You can see, because the volute covers what is inside. So if I want to turn the volute off, I just go to the browser and click toggle the on and off button there, and it goes off. So I can now see what is inside. And then what is inside now are just sketches that I use to make the volute. It is interesting to take a look at this one. So here you have, in this particular drawing, you have three circles, three planes, and on one plane you have a profile there, a curved profile on one plane, and you have another curved profile on the other plane. You have a three-dimensional helical curve joining both of them. Three-dimensional helical curve joining both of them at the edge. And then in the center, you have a straight line joining both profiles. And what we are trying to do here is to loft the profile at the bottom here onto the profile at the top to create a blade of a turbine. We want to loft the profile here to the profile here to create a blade of the turbine. And in order to do that, if I do, this is a loft now. I've lofted it, so you can see the complicated blade of the turbine, which is so simply created by taking the profile at the bottom here, this profile at the bottom, this is the profile at the bottom, and then this is the profile here at the top, this profile at the top. And this blade is created by taking a loft of the profile at the bottom and the guide rails. There are two guide rails. One guide rail is this vertical line here, and the other guide rail is this helical three-dimensional helix that is here. And when I allow the two of them to, when I loft procedure, it just creates this. The next thing for me to do is to now replicate this blade and make several copies of it in a pattern replication. If I do that, if I replicate that, so I have several blades now. So all that I've done now is that I've made the blade that I did, and that is the impeller. So I make it big, you can make it small, you can, and then I'm just using that to explain to you how the browser works. For instance, you will see here now that the volute is turned off. If I turn on the volute, you see the volute covers everything. You can't see anything because the volute is turned off. But if I open it, you can see. If you take a look, if you look inside this place now, you see those blades that we have just. Okay, or you can just turn off the volute and you see everything. Turn it on, you can only take a glimpse of it through this open space. So those are the kinds of things. So the browser is one of the most commonly used interaction tool with the drawing you are making. You can see here, you can see that sometimes I just upbeat my drawing as I like. I can take upbeats of the drawing And how do I do that? This, what I've just done is to hold down the shift key, and your middle mouse button, you hold it down, and as soon as you start moving, an orbit takes place. That is one way. Many things in Fusion 360 can be done in several ways. So you can see I'm orbiting as I want. I can take a look at any part. I can look at things from here. For instance, maybe let me just open this door there. The outlet cap. If I turn off the outlet cap, and I can orbit now, so you can see, you can take a look inside through this place. You can take a look inside through this place, and you can orbit all around like this. And then the browser here tells you, as I said, the browser here tells you that there are two parts. One is the volute, that is this one, that is outside. If we turn it off, you will see, we turn off the volute, you see the other part. That is the impeller there. That is the impeller there containing all those blades. And those blades are listed now as body one. Let me make that bigger so that you can see. Let me just show you. Okay. So if I keep clicking this down, this is body one, this is body two, body three, body four, body five, body six, body seven. So you can see all those bodies here. And if I turn them off, so you can see that of all those bodies, only one of them was actually created. Only one of them was actually created, and that one was created by lofting this profile on the bottom plate to this profile on the top plate using the three-dimensional helical curve here and the straight line here on the beginning as the guide rails for a loft creation. And then we can also, and then after that, we just replicated that in a pattern about the origin. I will show you how that, you will see how to do that later on. Okay, so all these things now, you can relate to this here. You can turn them off and on. There are so many things you can do with the browser. If you want to turn on the origin for the impeller, you turn it on here. The impeller gives you the origin. That's the origin of the impeller. And the origin just shows you the red axis is the x-axis, the green axis is the y-axis, and the blue axis is the z-axis. So you have red, green, blue axis. So those are the three axes. Those are colored axes. And if you want, you can open the, you can take a look at the origin. If you take a bigger look at the origin, see the origin is shown and everything is showing here. You can also turn things off. You can turn the origin of the origin off. You can turn the x-axis off. You turn the x-axis off, the red goes. Turn the y-axis off, the blue goes. Turn the z-axis off, the yellow goes. If you can turn them back on again. You can also see some planes that are shown in transparent yellow. Those are your XY planes, XY plane, ZX plane, XZ plane, and YZ plane. Those are three planes. So the origin contains the origin itself, which is 0, the XY and Z axis, and then the XY plane, ZX plane, and the YZ plane. Those are very important because when you are doing your two-dimensional sketches that create your drawing, you will need that information. But if you don't need the information, you may not want that origin to be on, so you can turn it off. Because there are other, each component has its own origin. Each component has its own origin. There are bodies that are involved in that component. All those bodies, sketches. There are sketches here. You have 3 sketches. This particular thing has 3 sketches. Sketch 1, impeller face, and top side belt. For instance, one thing we can do here is that we can turn the bodies off. If you turn the bodies off, you are now left with the sketches. So you can now see one sketch, which is that is the sketch there. Then the impeller face is the bottom plate, and then the top side is this. Those are the 3 sketches. So on the top side, for instance, we did the sketch, we did a circle here and this top curve. So if we turn that off, we won't see that again. So the impeller face is the bottom, but okay, let us remove the middle one. So you can see this is the bottom sketch. So you can see that's the bottom of the plate. It's a two-dimensional thing, but you can see a curve here that goes out of it. In order for you to see it, let us see how you can use the cube. For instance, if you take the front of the cube, you see the front view of this drawing. Let's see. This is the front view of the drawing. You can, if you go home, you take the home portion of the view cube, it will show you the whole thing in its three-dimensional glory. So this is the three-dimensional thing, and this is the front. This is the front view, and this is the right view. This is another view. All the arrows here can be used. You can see another view. You can continue using the view cube to see. You can take a plan view by looking at the arrow from top. That is the look from top. If you look from top, looking down on the drawing, you could also look from the bottom. If you want to look from the bottom, you can take the view here and take a look at the bottom. This is the view from the bottom. This is from the top. This is the view from the front. So the view cube allows you to see many things, different views of this thing. And but you can always go to the home. You can always go to the home view, and this is just one sketch. So that is the impeller face sketch. That is the bottom. So let me just show you the top face. The top face is another curve which of the blade. Again, you can take a look at it from the top view, two-dimensional view. You can take a look at it from the bottom view, from the front view or the bottom view. From any direction you like, or you can go to the home view. And then lastly, we take a look at this one, the impeller face, the sketch one, which is the middle sketch. So if you turn that one on, whereas turning the other one, so this other one doesn't have any drawing on it in this particular case, just a circle. So you have this drawing made up of 3 sketches. So you can decide to turn off all the sketches so you don't see the sketches. You can turn the sketches off and turn the bodies on. So you can see the bodies without, the sketches. So these are just the blades alone, without the sketches that generate them. So the sketches are there, but you just switch them off so that you can see the 3-dimensional bodies without any clutter. So that is, again, how am I doing this? I'm doing this by holding the shift key down and the mouse button, middle mouse button down. And then as I move things around, I can do whatever I like. I can move my drawings and I can see. So this is, as I'm doing this, you can see the view cube on the top. You can see the view cube on the top. The view cube is moving. So you could also achieve this by going to the view cube and dragging it and click on it and drag it up all around. So that is another way to achieve this. You can either use the view cube, and then you can see that the pivot was here. You can move that pivot to another point and then use the view cube to move. And then the view cube again can be used to look at any portion, top, front, side, left, all those kind of things. And then you can always go back home. Similarly, you can also go to the navigation. If you go to the navigation panel here and you choose orbit, then you have the orbit icon from which you can now just move this thing again around. You can see 3 completely different ways of achieving the same effect. You can achieve the same effect in 3 different ways. So you get this now, and it will continue to be active until you go back and until you press escape. If you press escape, you are back again, and then you can go you can take it home. You can also have constrained orbit. If you want a constrained orbit, you can click the arrow on the free orbit and you can choose constrained orbit. And in a constrained orbit, you can decide to move only, rotating around only a particular axis, and that may make for a little bit of constraint in your orbiting. So if you say, you can also pan the drawing. You can also pan your drawing by if you pan your drawing, you can move it. If you click, if you choose the pan, you get a pan icon. You can move it up and down, left and right, as you like. Now you can see the difference between this and the orbit is that you are just moving the drawing, you are panning the drawing, but you are not changing the orientation, you are not rotating. Then you can also zoom your drawing. So you can zoom your drawing up and in and out. You can do this directly with your with the mouse wheel. The mouse wheel it forward and backwards. It is going to show you bigger drawing or smaller drawing as you want. And then another thing you can do on the orbit, you can choose your display settings. You can choose your visual style, your mesh display, your environment, how it looks, these things, the effects, object visibility, your camera location, because this is a three-dimensional drawing. It can give you an orthographic camera or a perspective camera or a perspective with auto faces. Those are probably possible things you can choose here. And then you can also come here and choose your grid settings. Here, you choose your grid settings by checking the boxes, the layout grid lock, snap to grid. Sometimes you want to snap to grid. Sometimes you don't like to snap to grid because snapping to grid might be obstructing what you want to do. So, and you can set your grid, how dense or how sparse your grid will be. And then you can decide on whether you have incremental moves. So when you are moving, instead of moving in a continuum, you can be moving from grid point to grid point. So depending on what you want, you can set your increments. And the last thing here can help you to set multiple viewports. So you might be able to look at a single drawing from different kinds of views. And you can have 4 or 9 or many more views at once on your screen. Another thing I want you to see here is that you can also, let us take a look at the timeline. Let's take a look at the timeline. This drawing, you can go back to the beginning of the drawing. And let me allow everything in this drawing. I will make everything visible in this drawing so that you can see. So if I go to my timeline here and I can play the timeline with arrows. So if it's not shown, I've decided to show the volute and show its origin. So as I'm moving, it will go step by step. The next step, if I take another step here, you can see that it created this spiral here. This is a circular drawing that is changing radius. So the radius at this point has increased a little, increased a little until it gets to this end now, and the radius is more than before. So this is spiral that I have done here. And so you will later find out that Fusion 360 does not support spiral directly. So you'll be wondering, how did I do this spiral? You will get to know how it is done. It is, I did this spiral by programming in Python, but don't worry, you will get to see how that is done. If you don't know how that is done, you will see how it's done shortly. So I am playing the timeline here. I can move to another level. What I did next here is to draw two circles set at this point at a different angle. So you can take a look at this. You can see this circle. There are two circles drawn on the Z, on the XZ plane. These two circles are drawn on the ZX plane. How do I know? Because of this red and this blue. It's on the ZX plane. If I go back again to the three-dimensional view, you can see it here. So this is at a, whereas the spiral itself is occurring at the XY plane. The spiral itself is occurring at the XY plane. How do we know? We can from the top. If we touch the view cube and look at everything from the top, let us see what will happen. So you can see from the top, you can see the spiral here, this spiral here, and then the two circles are now appearing as a line here in plan view. If you look at it, if you look at everything from the top, it is coming as a plan view, and you can go back again in the view cube and look at it and go home. I will talk about the home view shortly. So you can see that is the second thing. So let us continue in this drawing and see what happens next. The thing that happens, the next thing that happens here, what is the next thing? I have another. Okay, so I want to go back. Okay, so let me just be sure that all my sketches are on. Okay. Yeah, I knew there was something wrong. So you can see, let's take a look at things from the right view. If you look at things from the right view, you can see that there were two pair of circles. There's a circle, there's a smaller circle here, and there's a bigger circle here. Both of them are on the ZX plane. Those two circles are on the ZX plane. And let us go back now to so you can see the center of the smaller circle is at the beginning of the spiral. The center of the bigger circle is at the end of the spiral. So for you to take a look at that again, let us look at it from the right view. So you can see the beginning of the spiral here. This is where the spiral begins from, and this is where the spiral ends. You can see that the beginning of the spiral is the center of the smaller pair of circles. And the end of the spiral is the center of the larger pair of circles. So what we are going to do in the next move, is that we are going to take a loft of this small circle. It will loft itself by going all along this spiral, and it's going to get bigger and bigger until it becomes the big, the small circles will start from here, and it will be lofted into the big circle. So this profile, the profile here, the profile of the pair of circles, the profile between them is going to be lofted into the big something here. So that is what comes next. So you see here, and that is what you have here. So you can take a look and see it here. You can see the profile. Interestingly here, it made it solid. It made it solid of the outer one. So since it made a solid of the outer one, so we need to borrow a hole using another loft that lofts the smaller inner circle and loft it to the bigger inner circle, and it will do that again as a loft. So let us see how that one happens. Okay, it hasn't happened yet. So what we did was to have an extension, and in order for us to see that extension, let us see the full thing here. So you started from here, and you made it bigger, and you extended it to something big there. So the next thing is, what's the next thing now? Let's see what happens next. You can see the next thing is that we now borrowed the hole. That hole was again done by a lock. Now a hole inside them, and that hole is true. How do I know the hole is true? I can use an inspector. I'm going to take an inspector here, and I'm going to select. I'm going to do a section analysis of this, and I'm going to select a plane. I'm going to select the XY plane. Okay, so if I select the XY plane here, I'm going to see. So this is how they, okay, so this is section. So this is the section. I can cut a section through it. So that section list is from the inspect up here. So if I'm tired of that, I can take it off. So I can continue play the timeline. What did I do next? So there are other sketches coming here. Let me just see in the volute. Okay. So it continues. There is this upper plate here and the plate which has not yet been done. Let us see when we continue our timeline. Okay, that one is covered. Okay, the volute inlet. Okay, let's see. We can go again and take a look at the. Just take a look at the volute inlet. Turn it on, and then we move. So this is the. So it is got an inlet through there. You can take a look there. There's nothing inside. So move this. Now it has finished doing the outer surface, which is the volute, is complete. So it has now started doing the second component, which is the impeller. So in order for us to see how it does the impeller, the best thing for us to do is to turn off the volute. If I turn off the volute, I'll look at the impeller without any problem. So here, I turn off the global origin so that I can continue. So if I move here, I want to turn on my sketches. Some things are off in the impeller. Okay, so you now see that that blade that we designed, that we did by lofting the other time is there. So let us make it bigger. And then the next thing is a replication of those things. And I think that is the end of this particular drawing here. So if I want, I can turn on my volute again and it will cover that. And you can see, if you take a look inside what is happening, you can see that the volute is there. Or you can also do a section analysis here. And I like to choose the XY plane here. If I choose the XY plane, so I can do a section analysis, and you can see how just take a cut through. Now you can see the blades of the turbine there so you can take a cut through that. So all these menus are things, as you can see, we can use them. We can use them as we get to learn how to use the environment. We can use them together. I will go back again and go into the menu. I mean, I go back to my slides, so you see how these things work individually. Okay, so I go back to, I've already explained that when you have the work, okay, let's see. Let me just see here. From the current slide, okay. So you can see by example that we have done, you see the way the browser works. You see how the browser works. Like I said, in this browser, you see that we have the volute and the impeller, which are two components, and each component has its own origin, its name, and then you have the bodies. Here the bodies that are defined are the backplate, the outlet cap, and the inlet cap. Here, in this particular view, I've turned off the inlet cap. You can also turn off the outlet cap. So you can turn off the entire component together. So you can turn off the entire component and nothing will show. You can also turn on the sketches that created the component, or you can take a look at one sketch after the other. Again, the other component is the impeller, which you can also open part by part. You can open construction planes and everything. So in the browser, several detailed actionable information on your design is presented. It provides you with optional ways of interacting with your design. In the example here, the browser shows us that we have two main components in the drawing, the volute and the impeller. So we've already explained how you can make some things visible and others invisible. We made the volute invisible so to see the impeller. The timeline shows the impeller at different stages. The impeller at one stage where we have just done the sketches, but we have not done the lofting. The same thing where we have now done the lofting. And then we still turn on both. We can now turn off the sketches so that you can see only the three-dimensional blade that was created. The view cube, at least I've showed you the view cube by action. The view cube has two components, a cube with X, Y, and Z axis oriented in a way that depends on the choices you make in your preferences. Okay, a home icon, this home icon that allows you to reset to a particular defined home anytime you want. We'll show you in our next demonstration how you can choose your home view. With this, you can view your design in several ways. You can view them two-dimensionally in any of the coordinate planes. You can move from one view to another as desired. You can return you want by clicking the home icon. The arrow down button helps you to set the home view. Set all kinds of let me just correct this. Set. You can set the kinds of views like orthographic, perspective, and projective. You can do that in the home view. You can also do that in the navigation panel below. So you have this. We'll show you what this arrow does. You can see that the red axis is the x-axis, the z-axis is the blue axis. Just get to know those colors so that no matter where you are, you know that whenever you see a red axis, you know that it's the z-axis, and the green axis is the y-axis. So that's your home cube. The home cube is just one way of doing some stuff. You can do those same things without the home cube. You might many times you might prefer to use your mouse and the shift key of your keyboard to be able to rotate and do the same things that you can do with your view cube. We have spent more than 50 minutes already, and I think I want to give you a break for how many minutes now? So we meet again at quarter past 3. So for you to digest what we have done, and I will get back again, 3:15. So you can take a break, everybody. Bye again. On the application bar, if you can locate the help menu, you go to learning and docs, self-paced learning and videos. What I want to do now is to go through a 5-minute video that is made by Autodesk. And then when I show you that video, you can go to that same location yourself and see other videos that are posted there. There are up to 20 videos, I think. And you have to watch all those videos at your own time. They are short videos between 4 and 10 minutes each. None of them more than 10 minutes. But they are action-packed videos that might really be very good for you. So like I said here, you look for the help menu in the application bar. Then from there, you go to learning and documentation. Then you choose self-paced learning, and then you move to videos. We're going to do just that right away. So we go to Fusion 360. The first thing is look for this. If you go on the application bar, at the top of the application bar, either the last or the second to the last, depending on how your system is set up, it's called help. There's a question mark there, help. You click on that, and you click on that, you see help like the learning panel, learning and documentation, quick setup, community, support and diagnostic, what's new, about. You will still use all those things later on, but today, we're just looking at learning and documentation, and then that one opens another drop down, which is the self-paced learning. There is still product documentation and Fusion 360 API. We are not going to look at those other two right away. We're going to look at self-paced learning. So I click self-paced learning. So when I click self-paced learning, what do I get? It's Mr. Admin. Can you hear me?
Yes,
is my screen clear?
Yes, sir.
Can you see self-paced learning for Fusion 360? Is that clear? Is that opened?
Yes, sir.
Okay. So you have self-paced learning. So when you get here, please take the trouble to read everything on this page. For instance, it says, getting started in Fusion 360 video series, 17 videos, beginner. So if you are a beginner, this is my preference to where you should go. Not those YouTube videos that are teaching you all sorts of things. These are the experts in this thing. So it is important to have a good understanding of 3D modeling before you make your first design. This 2-hour course explores the concept of Fusion 360 with a series of lectures and tutorials. So we just click here, start learning. You click start learning, what do you get? What you get is that you get the first video. The first video is 5.56, 5 minutes, 56 seconds. So let us see how this one works. So,
details, then you can use parametric.
No, I want to start from the beginning.
Fusion 360 is a cloud-based computer-aided design, manufacture, and engineering tool for collaborative product development. Fusion 360 combines fast and easy organic modeling with precise solid modeling to help you create manufacturable designs. When it comes to design, you can choose from integrated methods such as freeform, parametric, sheet metal, direct, surface, or mesh modeling. If your design is more on the artistic side, you can create a form and then manipulate faces, edges, and vertices to get your desired geometry. If your design has finer details, then you can use parametric modeling, which ensures your design has a timeline. So any design changes are captured and updated throughout the model to ensure the correct form and fit. If your design has sheet metal parts, you can use the sheet metal tools to create flat patterns while compensating for bends. To design without any restrictions, you can use the direct modeling method to translate, rotate, and change geometry without breaking a complex feature. This is useful for quick edits, defeaturing, or repairing imported geometry from other CAD tools. To patch up openings in a model or create other complex designs, you can use surface modeling. If you have scanned files that are brought in as an STL or OBJ, you can use the mesh tools to repair or edit the files. Fusion 360 gives you the flexibility to choose your preferred modeling method when it's most convenient in your product development process. Even combine them to create innovative designs. Next, the generative design approach will simultaneously synthesize multiple CAD-ready solutions based on real-world manufacturing constraints and product performance requirements. When you've created your geometry, you can assemble the pieces and ensure the proper motion is captured and restrained. Assembly modeling will describe the working relationship between the components with joints, such as the sliding or rotational joints. With joints, you can limit the range of motion, add cause and effect, and other relationships. Before moving forward with the design, you can simulate it inside of Fusion 360 in the simulation workspace to validate the design. You have the choice between study types like the common linear static analysis, the thermal model frequency, buckling, and many more. You can offload the study generation to the cloud, which enables you to generate more studies without using up your own computing power. So you can go through more study types and more iterations to gain valuable insights about your design. Ultimately, you use this insights for better design decisions. At whatever stage of the design process, collaboration is made easy with Fusion Team. Whether you're on a Mac, PC, web browser, or mobile device, use Fusion Team as a single place to discuss, mark up, and collaborate on designs. You can also use Fusion Team to manage your team and projects. Once you've had feedback and finalized your designs, you can create high-quality renders to document your designs. When you're ready to send your designs for manufacture, you can create production drawings. You can lay out views, add dimensions, tolerances, and create a bill of material. To aid any drawings, you can create animations to help describe assembly or disassembly procedures. By the end of this Getting Started 360 course, you'll build a strong understanding of how designs are made and assembled. This design forethought will make those inevitable design changes easier when designing for your own applications. Once you're familiar with the design processes, you can continue your learning journey by learning about using the manufacturing capabilities that come within Fusion 360, so you can transform your designs into real products. To program your part for manufacturing, Fusion 360 has toolpaths for 2.5, 3, 3+2, 4, and 5-axis milling. In addition, turning and mill turn, and 3D profiles for water jets, laser, or plasma jobs. To help improve your workflow, you have access to a fully customizable tool library. On your machine, reduce setup time and increase process reliability with automated probing cycles. With an extensive list of finishing strategies, you can tackle any geometry to get your part machined. You can also access tools for additive manufacturing. Here, you can generate a toolpath for your additive process and then simulate it so you can have the confidence that your part will come out as you expect. Lastly, you can use the electronics workspace inside Fusion 360 to create electronic designs. Create your schematics and PCB designs and then export your file for manufacture. As you can see, there is so much to unpack. We hope you're excited about your learning journey with us. Thanks for watching.
Okay, so that is one out of 17 videos that you can get from the, that's one of 17 videos that you get from the Vision 360 safe-paced learning. So that gives you an idea of what I'm talking about. So let us go back to our video. So let's go back to the PowerPoint. And admin, can you see my PowerPoint?
Yes, sir.
Can you see the PowerPoint page now?
Yes, it just moved from. Yes, I can see it now.
The application bar, page 7?
Yes, sir.
Okay, good. So like I said, there are 17 videos there. Now, if you've done all of those and you are still not satisfied, then you can go to be looking at the no-name products on YouTube and help yourself. But the videos made by the manufacturers are accurate and very powerful. They are short videos. A 5-minute video will take you at least, at the very minimum, 1 hour to really fully digest. So there are a lot of things that are packed into those 5 minutes. So, and they just go through them, and will assume by the next lecture, I will assume you have watched at least 8 of them, the first 8. So go through them. I'm not going to repeat too many things that they've already dealt with in those. I'm just going to add to them and then explain how you understand them. Or if you have questions, there are still things that are not clear to you, I will explain, but I do not want to repeat, because those people really make very good videos. And for that aspect, and serious students can actually move very, very fast through the learning videos. So you remember again, you go to the application bar, you choose help. From help, you choose learning and documentation, then you choose self-paced learning. And then when you have the web page, you go to look at the videos, and it gives you the first one, you go to the second one, and so on, and take your notes. It's not everything they are talking about that will be relevant to you because it is exhausting, but you will learn enough for you to get started. And on the basis of that, we're going to do a little bit more work in class. So like I said, upon normal launching, you get to the design workspace, which gives you solid surface, sheet metal, and tools. I'm going to go through a typical testing, a typical way to just draw some few simple things shortly. And then you have tools that you can select. Some tools are available for multiple things. Then you can have all these other workspaces, which we will not look at immediately. But I want to just make a comment on the simulation workspace. The simulation workspace is where all the equations you are going to arrive at in your strength of materials, mechanics of fluids, mechanics of machines, thermodynamics, elasticity, plasticity, and all the things you are going to learn in mechanics and design throughout your stay in the university are already known to this software, and they have already been pre-programmed there. So that once you want to do any design, you can just go ahead and you can just go to the simulation workspace. What your education at the university does for you is that it helps you to understand what those things mean. Now, you go to the web and you see a YouTube person who probably studied fine art and he has learned Fusion 360, and he will tell you, oh, forget everything about what they are saying in simulation. That is giving you wrong information because he doesn't know it, and he can only, water doesn't rise above his level. It can only tell you what he knows. It is not everything that is on the web or that is in this thing that can be learned, but there are some things that require training, that require the engineering training, and simulation workspace is one of those things. If you do not understand, you will be seeing a lot of things that will come across there, like the von Mises stress, equivalent stress, and many of those things are deep engineering terminologies, which you can only get. You will not even reach those things until you get to at least 400 to 500 levels. So just make sure you learn it from the experts, not just learn from the people who are just playing. Now, if all you want to do is to be a graphic artist, of course, that's good enough. But if you want to use this thing as an engineer, you need to really learn from the manufacturers of the code, of the program, because they know everything about it, and they will put the top people. Sometimes the people because the people who wrote this code are top professors in top universities around the world. So they are not, and then some of the people who do the videos you have here are already engineers themselves. So they know what they are talking about. So depend on them, rely on them more than the random people on YouTube. I am not saying that everything on YouTube is bad, but depend on them too much. We've already talked about the browser. Now you know about the ViewCube. You know what you can do with the ViewCube. But I will go back again and look at, I've already told you about time-oriented design. I've showed you an example of how you can play your drawing back. You can also play it as a video clip. You can alter the timing of creation of aspects of design and gain certain advantages if you do it correctly. It helps catch lazy students when examining their assignments. If I give you an assignment and you just copy another person's assignment, I'll catch you because I understand how to use the timing. If your timing and everything is the same, I know that you have copied, because if you do your work on your own, there will be something, you will not do the same thing in the same order. So that's one way. So please make sure you do your own work. When you are submitting reports to me, make sure you do your own work. I've already told you about the navigation bar. This is the Orbit tool. This is the Pan tool. I've forgotten what this one is, but this is the Zoom tool, which you can also do with your mouse. The mouse wheel can do that. And then you can also have all these grid settings and so many other settings and viewports. Many of these things are not to memorize. They are just to be known by usage. So Then the canvas is where your drawings show up. The marking menu are the shortcuts to frequently use commands that show up when you press the right button of your mouse. So I'm going to go through this in order to conclude today's lecture. So let us go back again to the Fusion 360 environment. So in Fusion 360 environment, we are back here. Now I want to start with a blank page. So if I start with a blank page,
You can't see there, sir.
Okay, let's also wait a little bit.
It's showing now.
Okay, it's showing. Okay, so please, if I'm moving too fast, please don't hesitate to let me know so that the others might follow. Okay, so you can see this. This is what you have. If you start with design, and you can create. Okay, I think I want to start all over. Let us say from something. Okay, let us start from I'm starting from another fresh page because I want to start from the way it will appear. So on this page now, we are going to create, what do we create now? Let us create a three-dimensional L, a three-dimensional L-shaped object. Something very simple that has a part circle in the center of it. So I can start here and say create a sketch. If I say create, I am in the design menu, I say create, and inside the create, I can say create sketch. So when I say create sketch, it gives me an origin. The red axis, as you know, is the x-axis, the y-axis is the green axis, and the z-axis, which is the vertical, is the blue axis. Now, when I want to create a sketch, the first thing it wants is a plane. So I can choose this plane. This is the ZX plane. This is the XY plane. And this is the YZ plane. So that's one of the things the origin does for you. The origin gives you opportunity to choose axis when you need an axis, to choose planes. But you can see now that as I am moving my arrows around here, only the planes are lighting up because it is smart enough to know that what Fusion 360 is expecting me to do is to choose a plane. So because it's expecting me to choose a plane, the lines are not lighting up. If it was expecting me to choose a line, like an axis, let us say I wanted to rotate something around an axis, the lines will be lighting up. We will do an example like that shortly so that you will see when the lines light up. But now, only those three planes are lining up. Now, you may think that I can only create on these three planes. Don't worry, I can create on many other planes, but let us just start with these three planes. So you can see the beauty of turning on the origin now because the original document is on, and even if the origin is off, once you say create sketch, it will give you the origin. So you can even leave the origin on permanently by turning it on. Okay, now I can select any of these three planes, but I want us to look at other ways you can make the selection. If you turn on the origin, you can see that like as I am moving my arrows through the planes that are in the browser, look at the fact that the planes that are here, when I also selected, like for instance, the YZ plane is selected now, the XZ plane is selected now, and the XY plane is selected. So that shows you that I can either come here and pick the plane here, or I can go to the browser and pick the plane. Very often, you will see that the browser is the more powerful way to pick the plane, especially when your drawing becomes cluttered. When your drawings become cluttered, the browser will always work. You may have your drawing so cluttered that some of these things are hidden inside drawings and you have to switch off some things to be able to reach this plane, whereas the browser selections will always be available. So let us, for the sake of this first drawing, let us choose the ZX plane. If you choose the ZX plane, once you click on it, the first thing that happens is that you now have a two-dimensional page given to you. In this two-dimensional page, what I'm going to do is that I'm going to create Well, this is just, let us just make a simple drawing. I suppose I'm taking a line here. I choose create a line, and it continues following me until I choose that. And I close that here. So you can see this is like an L-shaped object. Now I want that L-shaped object to have something like a circular protrusion here. So I do that by creating a circle. I can do that by creating a circle, and I can do it by creating a center diameter circle. In a center diameter circle, you choose the center. You choose the center, and then you choose a diameter. So I'm going to make, I'm not really caring about the specific dimensions here. I'm just going to choose a center diameter circle here. And then if I'm happy, I can use escape. So I have created an L-shaped stuff, and I've created a circle. Now I want to make everything here a single drawing. So I'm going to use the modified part of Sketch. I'm going to use it to do some trimming. I'm going to do some trimming, and to do the trimming, I take the icon of scissors here, and I'm going to trim off this part, and this part. So you can see now that you have this like this. Okay. So I'm going to now, what I want to do next is that I want to create a solid of revolution. How to create a solid of revolution? Finish trimming. I want to create a solid of revolution, and I want the solid of revolution to revolve this drawing along this line. I want to revolve this drawing along this line and get a solid out of that. So in that, I can go back to my solid. Okay, first of all, I should first of all say that I finished drawing. That is a mistake on my part. I should have said the drawing is over. So, and I can now create a revolve. If I create revolve, what it wants from me, it says, it gives me this menu here. So the first thing is that it says I should choose a profile. It says once selected. It has already selected the profile here to be the profile to revolve. And then it wants me to select an axis, an axis to revolve on. So I'm going to choose this line as my revolve axis. Okay, and its angle is choosing an angle of 360. And one side, new body. If I'm happy with that, I say okay. So see what we have see what we have made in this short time. So this is it. So with that, just drawing that L shape, see what we have been able to create in a short time. See it here. So that is a three-dimensional object, and this is how it looks. And now, there are several things we can do. Depending on what you want to do, depends on what the particular thing you want to create, how it looks like. For instance, suppose you want to bore a hole here. You don't want this thing to be solid. Then if you want that, you can decide to do another drawing, and you might decide to do another sketch. So I can create a sketch. Now I want to create a sketch, and I want this surface to be the surface of the sketch. So I want to create a circle. I want to create a circle, and I want a center circle here. And I want the circle to be, I want to create an annulus here. So let us say I create this. And let me see where the sketch is. I want to turn on the body so that the sketch can see. So this is the sketch that I'm making. So what I want to do now is that I want to say finish sketch. So I finish my sketch. I can turn on the body again. And what I want to do, I want to bore a hole of this size inside this thing. So if I do that, so I can say here I can create an extrusion. Can create an extrude, and then it wants to know what type of extrude I want to create. Thin extrude. I just create a normal extrude profile. This is my profile, and where am I starting? Am I starting on the profile plane? Let us start the profile plane right now, and then are we going one side or both sides? We're going one side. Dimension. We would leave the dimension alone for now. Distance, leave it alone. Taper angle, leave it alone. And then the interesting thing is the operation. The operation I want here is not a new body. I want to cut through this old body. I want to cut through this existing body. So I'm going to choose cut. If I choose cut, so I will reverse the direction. I want to cut through that. Let us say I want to just cut it for a small distance. So if that is okay, I can say okay. So you can see I have gotten my drawing, I've gotten the object I have, and I got the hole, not all through, but just to some distance there. So that is it. Now, I can decide to cut another thing at this surface. Suppose I want to cut something that is not as thick as the previous one, then I can create another sketch. Can create a sketch. And now when I want to create a sketch, I want to use this inner surface as the surface of sketching. So there again, I want to do, this time I want to do, I want to create a center rectangle. So I want to take a rectangle and a center rectangle. And I want to start with this center. Okay. I want to create a center rectangle. So, and I finish sketch. So what I want to do next is that I want to dig through that center rectangle all the way down. I want to cut the material all the way down through the center rectangle. And again, I can create an extrusion. I create an extrusion here. And this is where I want to do. And now I've selected that profile. I'm starting from the profile plane. I'm going one direction. And the extent type now is to object. I want to go all the way to an object. The object I want to go to will be the bottom surface of this object. So to object, so the object here is the object is the bottom surface there. So it is going to do the calculation until it reaches that. So, and it's a cut, so okay. So let's see what has happened now. So you can see it has extruded from the top there. It has extruded from the top all the way to that object. And I don't need to do any computation. It does the calculation itself. So you can see the two steps I've done here. I extruded down in a circle, and then from that point, I extruded a center rectangle, and I extruded it all the way down. And here you see what I have. You can look at it from the bottom. You can look at it from the top. So this is, now this object I have created, I can decide to inspect the object. I can inspect it by taking this, I can do a section analysis of this object. So if I want to do a section analysis, it asks me to choose a face. The face I want to choose the ZX face. I want to choose the ZX face, and I can choose that ZX face from the browser. Okay, I've chosen the ZX face, and I want us to see everything directly. So let us say I want to move the thing so that you can see the ZX face. So you can see this is the inner, this is how, if you cut what I have just drawn in the middle, this is what you see. This is what you see on the ZX face. So you can see the original L shape. You can see the original L shape. You can see the part of the circle that we did there. And you can see the part of the cutting I did using a circle and the rest of the cutting using this. And that is a cut from the center, but you don't have to necessarily cut from the center. You can decide where to cut. You can cut any point you like. See, you can see where I'm cutting. We're cutting. Okay, looks like this. Now you can see this one. Now you can see this one. Now you can see the inspection. You can see the inspector goes through as long as you choose the surface. Okay, so that is one way to inspect. So cancel. Now I want to do another inspection of this drawing. I want to inspect using the XY plane. So I will choose my XY plane. I want to create an inspection and section analysis, and I want to choose the XY plane. Now, again, the XY plane has been chosen, and I can decide to inspect from here, or I can decide to go from here down. So you can see it is an annulus here. Now it gets to the point where we have that our center rectangle cut. So you can see everything here now. And then it gets to the point where you have that circle. You can see it here. You can see how everything is. So you can see the inspection of the entire thing from that direction. So these are the things that you can do with the inspector. The inspector can give you, one of the things you can do in inspection is to do a section analysis. What you have seen here is that you can see that I'm able to create sketches on the fly. In fact, but let me just make this a little bit more interesting. I want to create 4 holes along this thing. Maybe I want to bolt this thing down. I want to bolt it down in 4 places. Or let us make it more interesting. I want to bolt it down in 5 places. So I'm going to create a bolt hole here, and you see what I'm going to do the bolt hole. So I'm going to create a sketch again. Create a sketch, and this is the surface of my sketch now, and I'm using the pan. I can pick this and pan it up, and they say, but I don't need that. I could have used my wheel to do panning, but okay, let us have it that way. Now suppose I just pick an arbitrary point here, and I want to create a circle. I want to create a circle for my bolt. And no. I have to choose create circle. I want to create a center diameter circle. Okay, I take this point. I create a small center diameter. Okay, let us make it a little bit big. Center diameter circle. So that circle has been done there. Well, I can't see the circle, so let me turn off the body to see whether my circle is there. So the circle is there, even though it wasn't showing. So that is the circle I want. Now, the next thing is that I want to create another circle. Now, this is where you use your active new. So if I right click now, right click says, right click gives me a menu. And one of the things in the menu is repeat center circle. You remember the last command I gave. So I want a repeat of that center circle. So I take that center circle and I repeat it. Okay. So I repeat center circle, and I want to make sure that the new circle is not as large as the previous circle. So I want to make this one 10 millimeters in diameter. So let us see. Oh, that 10 millimeters is too small. So let me just change this to 12 millimeters in diameter. So this 12 millimeters diameter, and the outer circle is bigger than that. Now, if you want to know how big it is, you can go to sketch dimensions and check it out. Sketch dimensions, and then I want to look at how big this is. And you can see that that is 20.3. So I can make it accurate. I can make it specific. Maybe let us make that one 18. Let's make that 18. 18. So the outer circle is 18. The inner circle is 12. So what am I going to do next? I'm going to drill a hole through with the 12, all way down. So I first of all say finish sketch. So after I finish my sketch, I'm going to go again to create an extrusion. I'll create an extrusion, create extrude. In that extrusion, I pick this thing, and I'm going to allow it to go from the top profile to and the distance now is going to be chosen by the object to object. What object? What object? The object is the back plate here. So, and it is a cut. So you can see that I've created a cut of the inner. I created a cut using the inner circle, and that cut is gone through the bottom plate there. What am I going to do with the other? Let us turn on the drawing. I want to do another cut with the outer circular annulus. So I'm going to create an extrusion here, extrude. What I'm going to do here, I select this one. I'm going to cut it a little bit down, just a little bit, so that the bolt that I'm going to put there will be completely sunk in. If I'm happy with that, I cut it. So let us take a look at this now. I want to take a look at this. No, let me pan it up. So you can see it here. Let me turn off the sketches so that you can see without any disturbance. Okay, so you can see the hole there. You can see the in sinking there, so that you can put a bolt there, and that bolt will be recessed in. So you can see the trick to do that. You cut the inner one first, and then you cut the outer one only a small distance. You can do it in different orders. Now, the interesting thing here is that, cool, so what am I going to do now? If I want 5 of this around this, what I will do, I'm going to create a pattern. I'm going to create a pattern, and the pattern I'm going to create here will be, I'm going to use these faces to create a pattern. Okay, so I'll create a pattern. I want to create a circular pattern. And now, the circular pattern, the faces, and then I want to select my object. This is one face, this another face, and this is a third face. Those are the 3 faces I want to create. I want to select an axis. I'm going to use, there is no axis here, so I'm going to use this circular object, and I'm going to select its own axis, the axis of this circular object. So since there's a circular object, there is a generating axis for it. And now, what quantity do I want? Let us say I want 7. Put 7 here and click OK. So here is 7 places to bolt this thing down from. So you can see how I created only one and I replicated them around there. I decided to use an odd number to show you that it doesn't have to be any, it can be 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or any number you choose. So those spaces have been replicated there. So you can see, you can look at it from the back. So this is the small hole at the back. This is the big hole there. If you look at it from the front, this is the big hole at the front. Okay, so you can see the use of the menu there. Now, there are other things you can do. Right now, there are only 2 menus that are shown in this what we call marking. This marking menu here. This marking menu is a menu that comes on just by your right-clicking. Now, in this marking menu, you can do something better, even with this marking menu. You can include other things here. Right now, it's only extrude and filleting that we have here. We can decide if I want to create something, if I want to create something here, and I want that thing I'm creating to be shown, let us say revolve. Suppose I want the revolve to also be part of my shortcut. So see, when I pick revolve here, you see this ellipsis, this vertical ellipsis here. If I choose it, I can pin that to shortcuts. If I select, if I mark that pin to shortcuts, you'll see that from now on, when I have my marking menu, you can see that revolve is now one of the things that can show. So the menu you have in your marking menu is all of your own, can be all of your own creation. So when you see that there are several, when you see some commands that you think you might need often, you can put it in the marking menu and you'll see that your productivity is greatly enhanced by that method. Oh, I'm already at 4 o'clock. I'm so sorry. Well, ladies and gentlemen, I'm sure you can see how exciting this can be. I want you to go and watch at least 8 videos between now and next class. Then I will begin to give you assignments from next class. So just get yourself ready to do these things so that you can be able to cope when it starts bombarding you with assignments. Have a nice day. Bye-bye.